Hello friends. So in today's class we are going to see the concept that is differentiation. Okay. So already in the first year you have studied derivative part. See, derivative differentiation meaning is same. Okay. So in the first year part, in the derivative what you learned, that is the derivatives of some trigonometric functions, that is basic functions, that is derivative of sin x, cos x, tan x, sec x, cosec x. Okay, so you have found out the derivatives of this. Okay, as well as you found out the derivatives of polynomial functions. Okay, means some basic functions, the derivative you found out in the first year. Okay, that is with the help of first principle formula. Okay, but in the second year we are going to find out the derivatives of some different types of functions. Okay, not like first year by using first principle formula directly we are going to do it. Okay, that is, for example, like derivatives of composite function, derivatives of implicit or explicit function, derivatives of parametric function, exponential function, logarithmic function, and so on. Okay, so in the second year you are going to find out the derivatives of some different type of functions. Okay, so in this class first I will revise some basic concept that already you learned it in the first year. So let me revise that concept first. Okay, so what is meant by derivative? Suppose f is a real function, and C is a point. C is a point in its domain. Then the derivative of this function f at the point C is denoted by f dash of C, and is given by limit h tends to 0 f of C plus h minus f of C divided by h. So this is the formula to find out the derivative. Okay, so when we use this formula, when one function is given and one point is given, means at particular point we find out the derivative of that function. Okay, or suppose if I write the same formula in the other way, that is f dash of x is equals to limit h tends to 0 f of x plus h minus f of x divided by h. So this is again a derivative formula, but this is called as first principle formula. This is called as what? First principle formula. Okay, and with the help of this first principle formula, in the first year we found out the derivatives of trigonometric functions and polynomial function. Okay, so this when we have to use it, when function is given and one point is given. Suppose only the function is given, then we have to use this formula. But in the second year I am not going to make use of these two formulas. Okay, in one or two examples I may use, but for the rest examples we have to find out the derivatives directly. Okay, as in the limit. So when you take the definition of limit, that is limit x tends to 0 f of x is equals to L. Okay, and in that also we have taken the two types, left hand limit and right hand limit. Similarly, in the derivative also we are having the two types, left hand derivative and right hand derivative. Okay, so now let us take the first type, that is LHD. LHD means what? Left hand derivative. So that left hand derivative, how we can write the formula? See, we will make use of the same this. Okay, so LHD is equals to limit h tends to 0 f of x minus h minus f of x divided by minus h and RHD means what? Right hand derivative, that is limit h tends to 0 f of x plus h minus f of x divided by h. So I think you will come to know what is the difference between LHD and RHD. In left hand derivative, here h is negative, whereas in RHD h is positive. Okay, so you can remember that difference between LHD and RHD. Okay, so this is useful. Okay, this LHD and RHD. Suppose if any function is defined in the form of modulus function, if it is defined in the form of modulus function, that time we can use this LHD and RHD formula. Okay. And next, you have learned some rules of differentiation. You have learned some rules of differentiation. Okay, I will say rules of differentiation. Okay, in that three basic rules are there. Okay, first rule, u plus v, here u and v are the two functions. Okay, dash, u plus v whole dash. Here dash represents the derivative. Now see, before going with the rules, I will give you some other notations of differentiation. Now here I have given f dash of x or f dash of c. This is the notation of derivative. Okay, f dash of x. Okay, so dash represents for what? Derivative. Similarly, we are having some more notations, like for example dy by dx. This is the derivative notation, or you can say y dash. This is the notation of derivative, or y1 is again a notation of derivative, and already I have given f dash of x. So these are the notations of what? Derivative. You may get dy by dx, y dash, y1, f dash of x. All are having the same meaning. Okay, and these all are called as first order derivative. These are called as what? First order derivative. Means what? We differentiate the function only one time. So therefore it is called as what? First order derivative. But for our syllabus, we are restricted up to what? Second order derivative. Okay, so let us come to the rules now. So u plus v whole dash. Dash represents what? Derivative. And u and v are the two functions. So therefore its derivative is what? That is u dash plus v dash. Means if there are some of the two functions, then you can differentiate those two functions separately. That is u dash plus v dash. Okay. Similarly, you can write it for subtraction also. That is u minus v whole dash. It can be done as u dash minus v dash. Okay. This is first rule. Second rule is u into v whole dash. This is product of two functions. And this product of two functions, so therefore this rule is called as product rule. Product rule. Now how the product rule is given? Okay, that is you can write the derivative of first function, that is u dash, into second function constant. First function derivative into second function is constant, that is u dash into v plus. Now first function is constant into derivative of second, that is what? V dash. And this rule is called as what? Product rule. Okay, once again I explain. U into v. In that, take the derivative of first function. U derivative is u dash into second function constant plus, in between sign is always plus, second function constant, first function constant, take the derivative of second, that is what? V dash. And this rule is called as what? Product rule. Okay. Third one, u by v whole dash. U upon v whole dash. So this rule is called as quotient rule. This rule is called as what? Quotient rule. How the quotient rule is given? See, u by v. U is the numerator, v is the denominator. Okay, how the rule is explained? That is denominator square. Denominator square. So v square here. Okay, then denominator is constant. Denominator is constant into derivative of numerator. So numerator is u, its derivative is u dash. In between sign is minus. Now numerator is constant. Numerator is constant into derivative of denominator. Denominator is v dash. Okay, so this rule is called as what? Quotient rule. So this all the three rules are very important. Okay, so while finding the derivatives of some different functions. Okay, see this quotient rule, I'll explain once again. U by v, so denominator square, then denominator as it is derivative of numerator minus numerator as it is into derivative of denominator. Okay, and this rule is called quotient rule. Fine, so these rules you have to remember. Okay, and see, after seeing this video, please you go through the all first year trigonometric formulas as well as some polynomial formulas. Okay, see, for example, like derivative of sin x is cos x. Cos x derivative is minus sin x. Tan x is sec square x. Sec x is sec x into tan x. Cosec x is minus cosec x into cot x. Okay, and cot x is minus cosec square x. Similarly, we are seeing some polynomial functions, that is derivative of x to the power n is what? N into x to the power n minus 1, or derivative of a to the power x is what? A to the power x into log a. Okay, so already you are having the notes of the differentiation also. In that you will find all the derivative formulas. You please buy those all the formulas, so we can start the problems on that using those derivatives formulas in the next video. Okay, thank you.